Hello everyone. Welcome to the webinar about open source machine learning in MySQL. My name is Konstantin and I will be your host today. And I'm excited to introduce you today's speaker, Jorge Torres, CEO and co-founder of MindsDB, the open source platform that enables machine learning capabilities for MySQL and other databases. Jorge is a visiting scholar at UC Berkeley. His research in machine learning, automation, and explainability. And before starting MindsDB in 2017, he was working with the first US government CIO, Anish Chopra, building data systems that analyze billions of patient records. And this project led to the highest savings in millions for millions of patients. I hope you will enjoy the webinar today, and there are many interesting hands-on demos ahead. Please feel free to ask any questions in the questions tab on the bottom right corner of the screen, and we'll have a dedicated Q&A session at the end. Now I will silence myself and hand over to Jorge.
Hello, everybody. Hope you can see my screen. I would like to walk you through first, what is MindsDB, what are we doing, and to give you a set of intuitions about the abstractions that we bring to the table and why MindsDB became such a popular open source project and why it can be useful to you. And then after that, I'll walk you through some examples, and Patricia will close with some other examples as well. Okay, so MindsDB right now is the fastest growing applied machine learning project in the world. And this is thanks to an incredible community behind MindsDB. MindsDB is built by hundreds of contributors now. And we're super excited to continue to grow on features that are important for our users. But the reason why MindsDB became the fastest applied ML project in the world, it's because of the way that we see the problem of applying machine learning. We think that MindsDB could become this AI brain for MySQL databases initially, and then we expanded to a whole bunch of other databases. But what we understood is that there's a whole bunch of ETLing when people do machine learning that is unnecessary. Let me give you this example. When people have a machine learning model centric approach, they start by creating a model and then they do extractions of the data that they have in, say, a MySQL database. And then they put this data in a file and they start transforming this data in pandas. And eventually they go through this iteration of transforming the data in pandas, create a model, transform more of the data, create a model, and eventually they have a model that works. And then when they want to move this model into production, now they have to create some infrastructure to put the model. So put this model behind a web interface or like a web endpoint, RESTful endpoint. And then they also have to put the system that does the ETLing in some orchestration system, some ETL system like Airflow, etc. And every time you want to make a prediction, you have to call the ETLing pipeline so that you can transform the data so you can fit it to the model. And many times applications that need to consume the model, they cannot call the ETL pipeline. So you have to do this in a ad hoc manner. So essentially you run the ETL pipeline, you create the predictions, and then you dump the predictions back into the database so you can actually consume them from the application. And we thought that that was a lot of unnecessary ETLing. So with MindsDB, we decided to do something different. We decided to allow people to do the modeling directly from data that they have in MySQL and in their database, and then to be able to make abstractions that will be simple enough for people to consume that data the same way that they consume data from tables. And let me walk you into that. We created this super simple concept, which is AI tables. And essentially, what an AI table does is it allows you to see and query machine learning models as if they were tables. So you can make predictions by querying a model, and whatever you have on the where statement is the input for the model, and then it returns that information as if that information exists in the database, even though they're just a virtual table. And the way that you create these tables is very similar to how you create a view. I'm going to walk you through an example or a set of examples that will show you the power of this. And the simplicity of MindDB is really what makes it so interesting. So just give me 1 second. I'm going to share my screen and we'll proceed with that. Okay, so anyone can deploy and install MindDB via Docker or via pip. Please, if you're interested, I invite you to go to docs@mindsdb.com, and there you will be able to follow the instructions for most of what we'll be showing here. But also know that we provide a cloud demo instance for anyone. So you can do pretty much everything that you can do on a Docker deployed image, but without having to go and deploy it yourselves. And if you want to like move it into production, we can help you manage that as well. But the idea here is that what I'm showing here, and we're going to share this set of queries as well. But what I'm doing here, anyone can replicate, and this is something that anyone can use. Now, MyCB brings the capability of connecting your database, but also know that even though right now I am connecting to MyCB via our web client, you can connect to MySQL using any MySQL compatible connector. So MySQL supports the MySQL Wire protocol. So anything that you use today, dbeaver or anything that can talk to a MySQL database can connect to MySQL. So MySQL is fully compatible with the MySQL Wire protocol. Now, when you connect to MySQL, MySQL behaves like a database. It's just that it stores models as tables, and also it leverages on external databases to bring data. So let's walk through that. MySQL allows you to create projects, and in this case, I'm going to create this one. Oh, sorry, I had already created prior to this. But when you create these databases, they're like virtual encapsulations that allow you to group information within a project, and therefore allows you to kind of work within a namespace. As soon as you create this, it gives you like the models table and the model versions. For the sake of this example, I had already like pre-trained 2 models, which I'm going to show you how to train. And don't worry, all of this will make sense as I walk through the demo. But let me use this particular database, and I'm going to look at what engines are available. Engines are the machine learning capabilities that MySQL provides by default. So we have one that is Lightwood, we have OpenAI and Hugging Face. There's a handful of those that are coming down the line, kind of like integrations to Nextlab for time series, integrations to other NLP capabilities and other AutoML frameworks. But just so you know, Lightwood is for anything AutoML, OpenAI for generative models and language, and Hugging Face for a huge collection of language models. And we're going to use the 3 of those. Now, I'm going to connect to a MySQL demo database that we have provided for this example. And the way that you do this is very similar to how you create a database. It's just that this database doesn't live in MySQL. It lives outside MySQL, and MySQL just points to it. So what we do here is create database, and then you tell it to use the MySQL engine, and you're going to pass your credentials for this. Now, this is a demo public instance that we have for you as well, so you can go and connect and play with it. But let's follow this example. Now, as soon as we run this, we see here that we have a new section here in the menu, and then we have many demo data sets that you guys can go and play with and build machine learning to kind of learn. There's also here the learning hub. So if you guys want to follow any of the examples that we have for, either forecasting regression, time series, classification, etc., please have a look at that. Now, anyway, for this particular example, we're going to start with the Hello World of MySQL, which is a home rentals data set. Let's look at that data set for a second. So home rentals data set has a few columns. It has number of rooms, number of bathrooms, square footage, location. It has days on market, initial price, neighborhood. Um, and what we want to do here is we want to create a model that allows us to predict what will be the most ideal rental price for a property given some information that we have. So let's go ahead and do that. We're going to create a model called home rentals, and we're going to train this model from data that exists on the MySQL demo database and this table home rentals. So let's go ahead and do this. So now this is being generated. So as soon as you run this model, you can see that home rentals using the engine Lightwood for the project MySQL demo, it's being trained. For the sake of this example, I had already pre-trained the model. So the models that exist out there. Um, so yeah, right now we have the home rentals model that we're training here, and you can actually look at all the models that we've been training. Yeah. So you can see that we have home rentals pre, home rentals pre-classifier. You can also see this information in the namespace that we have, this one. So again, we have models, we have the model versions. It will show you like different versions that we have for each particular model that we have trained. And the one that is being trained right now, which is this one, and the ones that I trained before. Now, let's inspect a little bit the one that we just trained. Okay, this one is being trained, but the one that was pre-trained. So what it's telling us here is that this model had used three types of encoders. It used the neural network, XGBoost, regression for the mixers of how these models are being built. And it realized that the XGBoost is the one that performed the best. So essentially has like a 100% accuracy. And therefore it picked that one. So the R square is one, sorry. And the idea here is that we can now query this model as if that model was a table. So how does this work? You can tell it, I want to select rental price and I want to select the explanation of that prediction. When, say, for instance, I have a property of 823 square footage, location good, neighborhood downtown, and days on market 10. So let's go ahead and do that. And essentially what it's telling me, well, for that property, the rental price that you're expecting is 2,814. Yeah? And the predicted value has a confidence of 99% and is not anomalous, this data point that you're giving. And also the confidence bounds or like the confidence interval is between 2,700 and 2,900, which means that it is 90% certain that that prediction will land anywhere between 2,700 and 2,900. Now, another cool thing about MindsDB is that since you treat models as tables, now you can join and do bulk operations. Say, for instance, you have a whole bunch of home rentals properties and you want to now predict them all in one single statement. In our particular case, we actually want to know how the model is performing versus some data that we already have. So what we're going to do is we're going to select from the actual home rentals data set that we have in our MySQL database, and we're going to join this with the model that we just trained. Or the one that I had pre-trained. Actually, let's go and look at the models and see if the one that we trained is already has it completed. Okay, it's completed. So let's actually use that one. So I'm going to join this. Well, it's completed. We can see it here. Anyway, so we're going to join this model with this model with the data set that we have. And we're going to select the column real price, that is the price that exists on the actual demo database that we have. And we're going to compare it side by side with the predicted price, as well as some of the attributes. So let's go ahead and do this. So this is pretty cool because we can see that the real price and the predicted price are not too different from each other. This model is actually pretty good. It's not really far off at all, and that means that this model is pretty good at predicting what we want to predict. Anyway, let's jump into a more complicated example, which is classifying the sentiment of Amazon reviews. This is pretty cool because it brings all the power of NLP to databases like MySQL and allows you to do I apologize. Allows you to do things that before were almost impossible directly from a database like MySQL. And in order to illustrate that, let's first look at the data. So we have um, information about different products in Amazon, and we have the reviews. So, and what we like to do is understand what is the sentiment of this review. Yeah. So this is a common use case. In all databases, most people at some point end up storing information like this one. Pure natural language, pure plain English, and you want to extract meaningful data from that. So let's do that. We're going to create a model. Um, and we're going to create a model using the Hugging Face engine. Now, Hugging Face has hundreds, maybe by now thousands of different models, and you can use many of those in MindsDB, and we're actually expanding the catalog. But there's one that is the kind of like the hello world for classifying text, and it's called the Roberta base sentiment. Now, what we want to do here is we want to take input from a column called review, and we want to get labels such as negative, neutral, and positive. You can pass whatever labels you want, and at this point, the language model will try to infer those. Now, the cool thing here is that with one very simple statement, we're going to bring the capabilities from Hugging Face directly into the database. And we're going to be able to query this model the same that it was a table. So I'm going to run this, but again, this is going to take some time because bringing a model from Hugging Face and loading it into MindsDB. But for this example, I had already trained this one before. So let's use that one. Now, let's look at the status of the one that we just had. And what it's saying is that it's generating. Let's look at the one that I had before. That one is complete. So let's first test this one. What we want to do is get the sentiment for a review, and it says this is easy to do NLP with MySQL, or it's easy to do NLP with MySQL. And what you get is that, okay, it's positive. Let's just say, let's change this a little bit. It is awful. It's not great to do NLP without. And um, and like that, you can do it for like most language sentiments. And it's telling you, okay, more information about this prediction, etc. Now, let's make a bulk or batch prediction. So what we want to do here is we want to go back into the data set that we had, which is the Amazon reviews, and join this with this model that we have, uh, and see what happens. So let's go ahead and do this. So check this out. You have the review, and you have the predicted sentiment, and this is almost like magic, right? Like this information didn't exist in the database, but all of a sudden you're just getting a sentiment column for each one of the rows that you have, or a sentiment assessment based on the model that we had. And this is pretty useful in the case of having data that you right now cannot extract value. If you were to do this otherwise, you're going to have to extract, say for instance, the Amazon reviews, run your model in Python, and then put the data back in the database. But now you can do those operations, in real time. And it gets even more interesting. Let's say you have actual meaningful information in this document, say in the review, that you want to extract. Say for instance, you want to extract the uh, the price, the location, the number of rooms from a description that you have. So let's go ahead and create that. Um, one second. Let's create one that says, what is the product? Name. Um, and okay, so check this out. This is going to be um, really cool. What we're going to do here is we're going to ask a model from OpenAI to extract meaningful JSON data from simple questions. So, like, what is the product name? What is the sentiment? And does the product work? And we're going to do this from review. Let's go ahead and do this. So we just created this model using the OpenAI integration that we have. And let's join this model. Review JSON creator. Actually, we have another one here. And let's join that with the Amazon reviews. Now, check this out. I'm testing. I created two models. I created this one that has rating and essentially telling it, okay, score the sentiment of this review from 1 to 5, the theme, and the age. And I had another one that is actually asking like more plain English questions. And let's rate them both. So what we're doing here is we're joining the Amazon reviews with review JSON generator, and we should be able to extract this rating, theme, and age. So let's see that. So here is saying the rating is 5, theme it doesn't know, and age 9. So check this out. Easy for a 9-year-old, and yeah, it seems like he's very happy with it. So you give it a 5. This is in my opinion like almost like science fiction. You have I'm not thrilled with this proprietary OS, etc., etc. So it's saying, okay, well, rating kind of 3 because it kind of needed it. The age 40s. Let's see. Let's look at that. Somewhere in there must be this information. Anyway, let's try the other one that we have, which is the one that should join reviews JSON creator with okay, let's see. So it's saying, okay, the product is a late gift. The sentiment is very happy and works easy, works yes. Anyway, now you can really take text and extract meaningful JSON information that then you can use for your analytics. Anyway, I'm going to pass it over to Patricio, and he's going to walk you through some other examples.
Yeah, thank you, Jorge. those are some great use cases. Let me try and share my screen. I'll show you one last example that has to do with how you can leverage really MySQL to do native database operations to essentially like bring the gap even closer um, from the database to machine learning. So first of all, let me very briefly show you a data set that we have here. It's a data set from an e-commerce website. It's a bunch of records of invoices, really, where you have associated products, their descriptions, the quantity, the invoice date, and so on. The relevant columns here would be the country of origin, the unit price, and the quantity most of all, because we will actually be doing a forecasting model. The main innovation, or well, the difference between this example and the ones you have seen already with Jorge, are that in this case, we're creating a view for training. And views are a very natural way, in our opinion, to perform feature engineering. In this case, I am creating a view called ecom for e-commerce underscore view. I'm just putting the number 2 here because I already have one pre-trained, well, not pre-trained, pre-created. And you can see that there's like a nested select here. So in the first one, we're specifying like for MindsDB, what's going to be the database that you're connecting to. And then inside, we have a native query, which means that you can do whatever you may usually want to do in MySQL, leverage all the features, the awesome features that you know it has, because this is passed straight through to the database. So in this case, you can see a very, very small piece of feature engineering, so to speak, where we take the product of 2 columns, the quantity and the unit price, for the and just mention that it is the invoice total. We're like essentially generating a new column, and you can query this as usual because it lives in the project, which is MindsDB by default namespace. So here we are selecting from that view a bunch of records. And you'll see in just a second, I think, the invoice total, which is the product between those 2 columns. So this is quite useful. You'll see why this helps the lifecycle in just a moment. But the interesting point is that when you go and create a forecasting model, in this case, you will see a small difference in the syntax. In this case, we're ordering by a column that declares the temporal nature of your data. You are partitioning set data by some column, which essentially defines multiple time series in the example. And then you're defining what's the relevant context window. In this case, we're setting it at 24, fairly arbitrary number, but for the sake of the example, it works well. And then the horizon would be how long is your predicted forecast going to be? So in this case, we're using the last 24 measurements on the data set to produce the next 12. And in this case, I'm not specifying a different engine. So by default, we're using our AutoML Lightwood, but you could potentially use another ML engine for forecasting, or rather with forecasting support for training this model. I'll just train this one. Again, number 2, because I already have a pre-trained version that you can see here in the models versions table, a bunch of them actually. And once it's trained, you can actually check some stats as before, as Jorge was saying. And when it comes to predicting, you can predict, because it's a time series, you can predict with some special clauses that we have for the bulk prediction. In this case, we have a temporal filter that says, please bring me the latest relevant records in some partition of the data as specified by this filter right here. So where the country column equals France, I want to go back to the database and figure out where does the limit lie in terms of the most recent records. And in this case, we're actually going to the view. So it's first going to the view, which is then going to the database. If it were a materialized view instead, it would just stop in the view because you would be storing those records in MindsDB. However, the cool thing is the latest keyword enables you to very quickly get to the relevant portion of your data where you want those predictions to happen. And if you run this, you will get forecasts for this particular group for the predicted quantity, which in this case is the total invoice amount. So this is all good and convenient. However, remembering or going back to the fact that we used a view, you can now start thinking about ML ops, like what's going to be the life cycle of this model. Presumably, the data can change quite a lot as time passes and your models stop being up to date and you need to retrain them, right? Well, in that case, the natural answer that MindsDB provides for this scenario is the concept of jobs and then also retraining runs. So you will notice that I have a create job syntax here. What it's doing is it's asking MindsDB to every 7 days start, and of course with an end date this is not going to trigger because it's way too soon, but if I change the timestamp to something that is beyond March, let's say April, we're essentially creating a job that will retrain the model every 7 days using this retrain clause, which is only going back to the view. It's compiling all the data that can be both new and old, and it will retrain the model from scratch. There's another type of retraining functionality, which we call adjust, but you can think of it as fine-tuning. It's pretty much the same concept. You don't train from scratch. Instead, you modify very slightly the underlying model. And with jobs, I will create this one right now. With jobs, you can chain commands. Like it's almost as if you were in the editor, but every once in a while you can run a bunch of commands that will run sequentially. You can specify points in the execution where you have to wait until the previous step has finished. So for example, if you were to retrain a model and then predict from it, you would use some special syntax to block it so that you actually use the new model. And just, again, for reference here, we can see that we have the actual job in the jobs history table, providing all the necessary details, when it's starting, when it's finishing, and then as well, if there's any errors with that, you can actually check them and even hook into them with webhooks to know that it's happened. So with this example, you can also sort of see the potential in this framing of machine learning applications when you start automating those jobs for you and handling retraining, fine-tuning runs, and even prediction runs, all of them automatically. You can insert into some table that stores all of your predictions with a job. So let's say you need that for like every 5 minutes you need to do a prediction call, you can automate that with this as well. So a very interesting bit of the MindsDB ecosystem as well. And that's everything I have for this example. So I think back to Jorge for, Infinite Mirror, for the wrap up. I'm not sure how to stop sharing though. There we go.
Yeah, thank you, Patricio. Okay, well, I hope that you guys found those examples very useful. We went all the way from like simple regression, all the way to text classification, to question answering from text to time series, which are, use cases that at least one of them will land into the problems that you may have to solve using machine learning. And all of that is connecting your MySQL database and to MindsDB, and then being able to do that all from your MySQL client. Now, let's go into the questions. The first one is, in every example, you are retrieving one result. Can you show as an example where you can join a table from a MySQL database with a model to predict a column? I think that we did that. So you can follow the examples that we have. There's a syntax to join a table, which we actually went and showed. I can actually share my screen again for that one. That one, just see. Let's see. So this last one, for instance, we took the MySQL Amazon reviews, and then we joined with the reviews JSON creator. And yeah, here you have, you can have the limit bigger than that. You can, let's make it 25.
Jorge, thank you. I think the part of the question is also like how it will perform with the larger joins, like for example, 1,000 rows or more. Can you share more about that?
Yeah. So it really is more about the complexity of the model that you have. So if your model is simple, it will perform that task quite effectively. If your model takes a long time per row, that's something that will take some time, but eventually it will give you the output. We are now working on parallelizing a lot of that. So essentially, it breaks it down into batches when you're doing like a really large join, so that essentially it's like a MapReduce problem. It instantiates many instances of that model, and then it allows you to join this in parallel. That's something that is to be released before the end of uh, March, and yeah, I think that right now you can do bulk operations with very large data sets and still get results. It may take a while because it's serialized. The next version that we will be releasing before the end of March will have parallelization when it comes to model joins. The second one from Ray is: Does MySQL store a copy of my data or just access my data without storing it? Yeah, it accesses your data without storing it. So when you do create database, an external database, and you bring it to MySQL, essentially it's just pointing to that. So when you run queries, it goes, fetches that data, does whatever it needs to do, and then it doesn't store any of that data. You can create views, and still, even with the views, it's just querying into that. We have debated or not on implementing materialized views, but you can materialize anything that you do back into the database. So you can create a materialized view back into MySQL with data that you have on MindsDB. So you can insert back into the database. So what you want to make sure is that you can leverage your existing database for what it is, which is storing data and querying it, and then MySQL to make predictions, and for those two to play very well together. There is: what ML engines do you support? Yeah, so right now we support Hugging Face, OpenAI, and then in Lightwood we support XGBoost. We support some elements of Profit for time series, and now we're writing continuing the integrations with um, Nixla for time series, as well as other AutoML frameworks. The objective is that before the end of Q2, we will expand at least to 40 different ML integrations. Yeah. Can I set up a pipeline that will automatically apply predictions to new data that flows into the database? Yes. Right now, that is possible with jobs. Um, I think that it'd be really interesting for us to do a webinar on jobs, because that's the way that you can automate tasks in MindSB. So essentially, you can say, I want to run this prediction every time, every minute, and only do it with the new data that is coming. We're also introducing the concept of events for this sprint, which will give you more data in the coming month. But right now, we finished this concept of jobs, and it's super useful for people that want to do predictions in the loop. There is another one. What is the process to update the model with a new training data? Yeah, we have fine-tuning models. So you can essentially fine-tune a model, and then you can see the model versions and use the most relevant version. So that's something that is supported today, and we'll point you guys to the documentation. But if you go to docs.mindsb, there's the adjust statement, which we're going to rename to fine-tune. Um, I missed the initial part of the meeting. Can we access the recording later? Yes, the recording for this webinar will be available to everyone, as well as you will be able to replicate everything that we showed on the demo, alongside with everyone is invited to go and try it out. In the Learning Hub, we have examples that replicate almost one-to-one everything that we covered today, plus more. What kind of triggers does job support accept time? Right now it's time, but the next iteration would be on streams. Um, I teach at the university and wonder, do you work with universities to help them teach this content? Yes, of course. We have done partnerships before with other content creators for education. So Platzi, for instance, had a great class on machine learning that people love. Happy to entertain this conversation further. Um, but um, but yeah, we anything that we can do to help you, improve people's understandings of machine learning is aligned with our mission, which is for people to leverage the power of machine learning to do great things. I understand that MindsDB works with various databases. Which one is the recommended one? No, the recommended one would be the one that you use for storing your data. So if you already have MySQL, then use MySQL. If you use Mongo, then use Mongo. I think that the game of MindsDB is to make it easy for you. And if your database is not supported, right now we have more than 60 databases that we support. But if the one that you have is not supported, or you think that could be supported better, we have a very active community. So it takes a matter of at most a week to get a new integration out. Can we get the files on Google Drive or files to practice? Yes, of course. We even have an integration to Google, and you can also link files through URLs. So there's a file section, and if you go to cloud.mindsb.com, that's the easiest way for you to try. So if you don't want to deploy it yourself, and then there is upload data from files, and then there's an option to do it through URLs. Is there any data size limit for the base data which I need to create a model? This is an active piece of work for MindsDB. So the objective for MindsDB before the end of Q2 is that we can support 1 terabyte of data. That is the objective that we have set out in terms of limits. So stay tuned to that, because we're doing great amounts of work for that, both at the inference time as well as the training time. Will this webinar be on your YouTube channel? Yes, I believe so. Costa, you're the best person to answer that question, but I think so.
The webinar recording will be available on the event page. So the same URL that you used to register the webinar, you register, you share it with someone else, and the people can access the recording. I will share the link in the response right now.
Awesome. Okay. So I believe that's all the questions. Let me go into chat. Will this be loaded somewhere? Yeah, that question.
Yeah, there's another question from Christopher. So I presume when using an OpenAI model, you're using your own API tokens. How do we know how many tokens MindsDB is sending? So that's a great question. We actually we have our own default API token for testing. But of course, if you have your own token and your account has greater rate limits or other parameters that you are actively paying for, then it's simple to just specify that API token when creating the model or the actual integration. You can create your own integration to OpenAI, and so all your models will be using that API key instead. In terms of how many tokens is MindsDB sending, that's a bit tricky to answer. I think the final, I think the best guideline there would be the max tokens parameter, which is the one that is exposed by OpenAI's API, and you can pass directly through our inference calls. So that way you can control how many tokens are being consumed.
Thank you, Patricio, for answering this. There is a new question from Samir. Can we create multiple models on the same data using different engine? What is the difference in each model?
Patricia, you're best to answer this question.
Yeah. So, well, each ML integration has slightly different behaviors within the actual AutoML process, so to speak. So some of them are much more focused on being robust pieces of work that just can intake any type of input data. Some others assume of the user, or rather the input data, that it's going to be structured in a specific particular way that the underlying framework is able to use. So take, for instance, Hugging Face. Some of the Hugging Face models require you to have your input data to look in a very specific way. So the main difference would be the use cases that you can tackle with each integration. So if you want NLP, you will probably specify OpenAI or Hugging Face. But then also there's the question of how does your data look? And if it looks messy, it's probably best to use AutoML for that, provided that you want a use case that is supported by it. And we actually have more than one automated AutoML framework. Recently, we have open support for AutoKeras, which is an automated version of the Keras neural network package. So depending on how your data looks, depending on what use case you have, the best engine may change. You can train multiple models with different, the same, for the same use case, have different models with different engines. That's not an issue. Just be sure to name them in a different way so that you know which options were used to create it. Hopefully that answers the question, but it's a fascinating topic, of course. And again, if some of the integrations you're planning on using are missing some feature, please let us know and we can take a look at improving each integration, because there's always more work to be done in AutoML.
Thank you, Patricia. And I think there is the previous question you answered about OpenAI. There is additional question for that in the chat tab. How the prompt might look like if we use token limiting. Isn't there a risk your prompt will be truncated, causing bad response?
Yes, yeah, absolutely. That is an awesome question, because depending on how the tokenizer works, your template for the prompt may actually cause your prompt to be truncated. So the best practice here is to err on the side of caution and set your max tokens option to be high enough that it supports your prompt. As for the actual templating that gets done, there's 3 different modes for this integration. 2 of them are very minimal, and they just almost literally inject the prompt that the user passes. But there's also other option, a last option that's much more flexible and enables you to fully control the template with multiple input columns inside. So hopefully with that combination, you're able to figure out a maximum of tokens that won't mean that you're truncating anything. But it's a really, really great question, and it's a subtle thing to be aware of.
Yeah, I just want to add that if you want to further explore on that with Patricia, feel free to join our community Slack. The link is available on our website, and find Patricia there and chat with him. Or you can post a question in or just questions tab, and the community can pick this up. The next question is from Konstantinos. Can I use an existing model I already have towards adding predictions in the MySQL database?
Yes, you can. So we support MLflow as an engine to bring models that you already have. We also support Rayserve. We'll post the link on the docs, but also we are releasing very soon for people that have dedicated instances or that they deploy through Docker, the ability to bring their own model. So essentially, just a Python file with a requirements.txt, and then you can actually use your own model. And this is something that people have asked for a long time, and we're super excited to.
Yeah, thank you, Jorge. Let's wait a couple of more minutes if there will be any more questions. So again, I want to mention that we have a community Slack, and feel free to join and ask any questions about how to use MindsDB, about like your use case. We have a pretty large community that is happy to help with any practical advice you have for building your AI applications using MindsDB and MySQL. And there is a new question that just came from Samir. Assume the query has exact data in the table. Select rental price from home rental where square feet equals 823. But if I create a model on home rental with prediction on rental price and use same condition, I get different result. Why?
Yeah, so there's a couple of reasons. First of all, it actually truly depends on the underlying model. If you have something that is a tree-based approach, there is a chance that that particular record got grouped with other very similar ones, and the model has learned to answer something that's really close to that number, but not exactly the same number. And that would just be a limitation or not a feature either. It's just more how the algorithm works per se. And then there's also another potential cause here, which is missing data. We by default impute some of the data when it's missing, but if you have a lot of missing data and you just provide some of the columns in the input, it's also likely that the model is going to struggle with that and thus generate a slightly different prediction or very different prediction depending on how the model works on the inside. But our default AutoML tries to do its best in the presence of missing data. So just talking about that one in particular, you should be able to get something that's kind of close. If it's another integration, maybe it's going to be very different. So very interesting question, of course. And the answer is, it depends, sorry to say.
And at the end, the best way for us to convey models is that they are at the end, they're just a virtual table. It's not necessarily that they're the same table that you trained on. What it is trying to do is trying to learn as much as possible from that data, but since it doesn't, MindsDB doesn't retain any data after the model is trained, at the end it's just making up a prediction and it's trying to give you the best guess. So if you want the exact answer, then you can query the table that you trained from. But if you want an estimate, then that's what the models will be for. Anyway, guys, I have to join another call, but thank you so much for joining us, and I look forward to seeing you for the next ones. Again, we owe you one for jobs, which is one of the most exciting features that we're adding, as well as the capability to bring your own model by just really dragging your own file, Python file, and then presenting that as a table. Plus, a lot more to come in terms of ML integrations, like the ones that we have with Nixla and other NLP capabilities down the line. So yeah, stay tuned because a lot of exciting projects are being shipped this month.
Thank you, Jorge. Thank you, Patricio. And thank you, everyone who attended the webinar today. Happy to see you all. And if you still have any further questions, please join our Slack community and we'll be happy to help you. Bye-bye.
Thank you. Bye-bye.